Thank you and very good afternoon to all of you. I think we have a very interesting topic to talk about on battery management and recycling. As we see that electrification is increasing by leaps and bounds in India, uh, the front runners, of course, being the two and the three-wheeler segment, along with buses and also four-wheelers. I think the most integral part of it is, of course, the battery and its management, whether it's during the life or in the afterlife once you take it out of the battery. And therefore, it's my proud privilege to be moderating this panel with an august gathering of experts from the industry who can share a lot of valuable information on this very important subject of battery management and recycling in the Indian context. So to kickstart the proceedings, maybe I'll start with you, Mr. Venkat Rajaram. You know, given your company Signi's expertise in EV batteries and energy storage systems, how do you perceive the role of the BMS in terms of performance and longevity in specific Indian conditions, which, as we all know, range from high humidity to drier climate, high heat to colder climate, and also not in all cases use, but also in many cases abuse of the vehicle as well. So in the face of all of this, what sort of challenges are there in designing a bespoke BMS, and how you've been able to do that as a firm? And then we'll move the conversation forward.
Sure. Thank you, Ashim. Let's start off with BMS, role of BMS in the battery. Today, BMS, the kind of compute power that is there inside a battery is as much what you found in a high-end mobile phone or in a laptop kind of stuff. So you have a microcontroller, you have storage systems, you have got communication interfaces, and so on and so forth. And the recent guidelines on the battery management system, had basically put the requirement at a fairly high pedestal, right? In terms of, need for a smart BMS, need for making sure that the data is all captured, need to make sure that we have an early detection in terms of, thermal runaway and so on and so forth. Having said that, right? So today, the BMS goes inside the pack, and there is a requirement where the packs are all, fairly well regulated now with an IP67, which is one of the highest level of protection from a dust or a water ingress and so on and so forth. And the BMS, the traditional functionality, right, in terms of, protecting the, against, electrical anomaly, protecting against a thermal anomaly, and then also algorithms to measure the state of charge, state of health. These are all now there in almost all the packs, right? So that's what's given now. But I also see a lot of new developments happening on the BMS, and they're all coming from the software side, right? So BMS is all semiconductor and software. On the software side, there is a new state of safety, right? If you were to look at the BMS, if you were to see, on this line of safety, where does that current battery pack stand? That's very important for a lot of manufacturers, right? So, and there is also a lot of state of functions, right? Because now you have, financiers who wants to finance this battery pack. You want insurers who wants to make sure that the warranty is provided. The state of function hooks and all are provided. And also that, the batteries is now all, digital communication devices, and then you have a digital cloud. That adds, lot more data onto the cloud, which makes the BMS configurable to various, climatic conditions, right? For example, if I were to drive a vehicle in Leh, Ladakh, under a low temperature condition, the BMS behaves differently. As against maybe driving in Rajasthan, under high temperature, it behaves differently. Lot of interesting work is happening on that, but I'll leave it up for more questions later, Ashim.
Sure. Thank you. Thank you for sharing light on, of course, it's the brain of the battery, and therefore it is working like the human brain, sensing what's the outside conditions. Thanks for sharing that. Moving across to you, Rituraj, we see that, you all have been talking about these fast charging solutions in the country, primarily focused on the three-wheeler segment and maybe also in the future for bus segment. And we understand the challenges that the battery has. We just heard Rajat talk about in the last session about putting steroids to the battery when you fast charge it, right? At the same time, we also know that the climatic conditions are hot in any case. How do you think some of these commitments to the customer around fast charging are being honored, say, across the year, depending on whatever season that is? And what are some of the significant steps you as a company have taken for that?
Hi everyone. Thanks, Ashim, for the question. My name is Rituraj. I take care of engineering at Exponent. A brief about us. We at Exponent are an energy company who believe in energy is a two-sided problem for EVs. So we take care of both charger as well as the battery pack. Now, one of the key USPs of our company is we do 15-minute charging for lithium ion batteries. So if a vehicle has Exponent battery, it's Exponent enabled, it can come to our charging station and get 0 to 100% charge in 15 minutes. So that's a bit of brief about what we do. Second part was, we mentioned about three-wheeler and electric buses. So at least at Exponent, we believe that the way forward is smaller batteries, which can be fast charged and give a long life cycle. And I think that makes sense also from the point that, especially if you look at commercial sector, initial cost matters. And if you're able to give a smaller battery comprises still of 30 to 40% cost of the vehicle, right? So if you can give a smaller battery, obviously there will come a range anxiety, but if you can actually do 15-minute charging or a fast charging for these batteries, that is taken care of. So especially for commercial side, we see fast charging adding a lot of value. So our basically motto is that smaller batteries is better for the commercial sector. You mentioned about fast charging and impact because of different conditions, right? So if you look at it, especially on the commercial side, I'll break down the problem into charging and discharging. A vehicle, be two-wheeler, three-wheeler, it takes 3-4 hours to discharge, right? No one discharges in 30 minutes until it's a very sports vehicle, so I'll leave that for aside. If it's discharging in 3 to 4 hours, the C rates are very low. Now, discharging at low C rates in general is very less detrimental to a battery life. So it comes down to charging. So today, even normal battery packs, if you don't take care of the battery while charging, it degrades. Now, with Exponent, because the charger is also Exponent and the battery is Exponent, we know what the battery is capable of when it comes to charging. And we have our own off-board cooling system and our algorithm. So when a battery comes to charging, we know where it stands, what is the best we can do for it, and we make sure that the cells are kept under the most optimized conditions, let's say. So that's one of the ways in which we take care of the battery.
Thank you, Rituraj. And I think you brought up a very interesting point around the size of the battery versus the charging rate of the battery. And, I think there is a lot of debate going around on that as well, that, can we minimize the environmental impact if we have smaller batteries rather than very big batteries because of whatever goes in making the batteries, especially extracting the raw materials. Therefore, on that note, I'll move across to you, Abhinav. With your focus on the sustainable corporate transportation, B2B EV platforms, right? How do you see, from the on-field data and usage, from the operator's perspective, their point of view between having fast charging capabilities as against having, maybe slower charging but larger batteries from a day-to-day use case perspective?
Yeah, thank you everyone. Good afternoon. Thanks for giving me the opportunity to sitting over this forum and sharing my thoughts among you. So we need to understand the B2B business from the root level, from the basics. This business is something which we always have a notion that B2C business is much bigger than the B2B. But on the other side, B2B in terms of unorganized sector, been working for a regional level, contained within multiple vendor at regional and the cluster level. So these are the things we need to understand. So if you're talking about the ecosystem comes with different stakeholders, whether it's been vendors, whether it's been charging point stations, providers, whether it's been a service provider like us, and whether it's been OEM. So everybody have this scope of work to be evolved, and in B2B market, for every customer, whether it's been a government sector, whether it's been a corporate, whether it's been a hotel and the hospitality sector, everybody have their own ways of customized and tailor-made solutions to be addressed. So based on that, every vendor has to come along with the different kind of solutions. If you're talking about the fast charging and slow charging, yeah, it's something which is evolving from last 3 years. If I'm seeing from 2018 onwards, we've been working with the EV capacity which runs on 4W for 100 kilometers. Now capacity has been reached to 200 plus with the help of increase in the battery size and the range anxiety. On the other hand, if you in terms of talking about the battery life, the slow charge and fast charge is something which we need to understand. To remain to give up time for the corporate to deal with the process to run on, vendors are more focused towards the uptime and the performance of the vehicle, which is approximately 90% of the vehicle utilization, which means utilization of vehicle can be done by two ways. Either we have to go for a fast charging or we have to go for slow charging. But the current scenario, the technology has been evolved so much with the new technology like Electra and so on in Tata Motors. Now the ratio has been become 4:0, which means you can go for a fast charging up to maximum level, but to reduce the fatigue of the battery to run it for next 5 to 6 years, you have to go for one slow charging and once in a week now. So this is something which everyone is looking for, and we are also working on that with the OEMs to develop the technology on that.
Sure. All right. Thank you. Thank you for sharing that perspective. Moving across to you, Amit, and that question of yours, and they'll dovetail to Anushri as well. But as the founder of One Electric platform for 2-3 wheelers, you have to deal with OEMs having different charging guns, different battery chemistries, depending on the vehicle that is there, and hence also the charging rates, etc. So, do you think it does make a case for having more of standardization in this era, in this sphere, so as to promote recyclability, for example, of the batteries, and also from the perspective of limiting the amount of infrastructure that you need to develop for it? We also see this happening now, say in phones with Apple and the others now all going to the C-type. Do you think there is merit in looking at this more deeply from a standardization perspective as well?
Yeah, so as Electric One, we are in almost 18 states across India, 100 showrooms, and we are selling electric scooters. We are also in Sri Lanka, Nepal now. So just a question for the audience, how many of you have driven a motorcycle or electric normal scooter in your life? If you can raise your hands, I just need to see the numbers. Any motorcycle? Okay, and how many of you have driven electric scooters? So it's quite a less number compared to the overall petrol. So I think that's the difference. As a common man, example, my father retired, and he asked me to buy a scooter for him because he was not able to commute properly in Kolkata. So I offered him electric scooter, and he told me, I have money, I can pay my own petrol. Okay, but then I asked him to drive it for a month or so, and then he got used to it, basically. So that's the difference between, testing the vehicle and seeing from outside. So lots of innovation about range anxiety and, let's say charging comes from the fact that we don't know yet the vehicle completely. So, and at the same time, coming to Ashim's question that, standard battery specifications, yes, they're very important. The issue is, it has to come from the regulation perspective more than OEM perspective, because everybody comes with their own different shape of specifications of batteries, configurations and stuff. So for a consumer, for the replacement, more than recycling, I am very bothered about the replacement. Somebody who goes on the road, he buys an electric scooter, runs for the next 3 years, and then he comes up and say, oh, I need to replace, he don't find a battery. Because nobody has the standard specified batteries in the replacement market. So that's a big market, and if it is regularized, the adoption will be much more higher, because people are concerned about the battery more than the scooters, the life of the battery, the replacement, the overall serviceability of the batteries. So it's more like a regulatory thing which has to come from the government side. This is my perspective, which I've observed.
Sure. Thank you, Amit, for that. And on that note, coming finally and very importantly to you, Anushri, on post the life of the vehicle, and we've seen case studies from across the globe of these mountains of waste that get created if there is not a suitable recycling infrastructure in place. In India, now that we've worked a lot on the circularity of vehicle side as well, we've seen there is a big challenge in getting this feedstock of, to constantly feed the recycling centers. I think that challenge gets even more magnified when we look at batteries, because on the one hand is getting these batteries in. Second, you may be recycling batteries which are of a chemistry or a composition very different from what the future batteries are going to be. So what you take out may not be as valuable. Thirdly, of course, as the technology changes, I think the recycling technology also needs to change in step so as to be able to safely carry out these processes. So given that you all are leading in this field, would like to know your perspective around these issues.
Right. I think it's a matter of grave concern as well. And as rightly you mentioned that we have a advent of all end-of-life batteries. But let me assure you, this is just the beginning. And there's a big tsunami of EV battery wastes are coming. Listening to everyone about the electric vehicles, and it's a great thing that we are going to this energy transition from the traditional method to the clean energy and green energy. But then what do we do with the end-of-life batteries? And let me tell you, as of now, it is not the big problem of end-of-life batteries because we haven't reached to the stage yet where we can get the mass amount of the end-of-life batteries. For example, I was just reading somewhere just for this event today that S&P Global mentions that by 2030, there will be 20 million advent of new batteries in the market in automotive industry. So what do we do about it? And what happens to this waste? Firstly, let's talk about the grave concern about why is it even important for this disposal. It's not about only health hazards, but also big-time environmental hazards. People do not know, like layman or us in generally, we do not know what an EV battery contains until unless we are from the OEM and everybody sitting in the room has good knowledge about it. But if we just dispose it in the soil, it has lithium, manganese, nickel, cobalt, etc., which seeps into the soil and eventually comes to the whole ecosystem, entering into your plates and the food and everywhere. So it is super hazardous, not just to the health, but also to the environment. And as you rightly asked, what do we do about it? So what we at Atero do is we recycle all end-of-life products, EV batteries, especially lithium-ion batteries, and also e-waste. Today we are since focusing on EV batteries, so let's just concern about that. And you asked a very good question about what if in 10 years or in some time down the lane that the technology we have, it just diminishes and the new advent of batteries, be it LFP, NMC, or any kind of LTO, LCO, any battery, are we even producing something which is viable for the market? So I can give a good example for that. Past 10 years, our R&D team, which is a very robust R&D team they have been upgrading themselves each year, and we have around 200 global patents nominated right now. We already got 40 patents in the technology aspect of how we are recycling, how is it, as a responsible recycler, how we come up for the society, and how is it relevant to close the circular loop of the circular economy. So that thing is there, which is taken care as of now, and will be, obviously, we need to upgrade ourselves with the passing time. And as you asked about the standardization of batteries, and my colleague speaker already spoke about it, it's well and good for us as recyclers because it's more standard for us. But right now, we recycle every part of it, every part of scrap, and the recovery rate for the end-of-life batteries is more than 98%. And the materials we get, it is a battery-grade material, and the purity is more than 99.5% of battery-grade material purity. So for us, for standardization, anytime it works well, but if we see on the other part of the society, I think it could be challenging, as my colleague rightly mentioned about how to change the charging stations and how we are moving ahead about it, and a lot of making changes. Even we know that moving from C-type chargers in Apple, moving to C-type chargers makes a life convenient, but what about the previous chargers we had? I cannot charge my iPod with the same charger, I still need to have 2 chargers at this time. Maybe it will take a few more years, but it is a good scope that we might look forward to.
Thank you, Anushree, for that very lucid answer on all the aspects of recycling. Thank you. Coming back to you, Mr. Rajaram, and when we talk about battery management, I think it's not just about the BMS, but it's also managing the battery through its life cycle in the vehicle. Right? So we've seen there have been umpteen number of cases of vehicles being launched, but not adequate service network being in place, and this is also for the mechanical and other electronic parts. But in particular for battery servicing, right? We don't see much of either the skill or the infra being developed. So what are your views on that? Because that is also a very critical aspect for us to be able to ensure that the customer gets service through the life of the vehicle, which is a given in case of ICE vehicles, for example.
Yeah. I don't think I have a great answer, but I can talk about, my thoughts on this in terms of, see, on one hand, we are talking about the plank on which electric vehicle rests is that of low maintenance, low service, right? So it's basically, that's one of the key factors, we sort of talk about when we are comparing that with an ICE. Typically the batteries, or for that matter EV, with the advent of this newer guidelines, needs very little service per se, right? Or, in terms of opening up or, doing anything there. But having said that, battery is also the key component. I think the other speaker talked about, 40-50% of the cost of the vehicle is that of battery. And battery servicing or repair is a very different beast when compared to repairing for a traditional ICE vehicle, right? So you don't have an aftermarket for this, and the servicing itself is very specialized. It's very multi-disciplinary in nature. You need to have your software, your data, your connection, your electrical, your chemistry. All of them sort of plays a big role. So this is, and the manufacturers, we are all, in the first few years, the problem hasn't hit us yet, right? But it's clearly, around the corner. So now what is the solution for this, right? So in terms of, so today, if we were to look at telecom, for example, right? Telecom, the servicing is done, across, the manufacturers, right? Today you have got a standardized set of servicing which are done in telecom. Something similar ought to happen for EV batteries as well. Right? Today, I think we talked about standardization a short while back. Non-standard batteries and then not able to sort of, share the data, right, between one manufacturer to another. And it requires a very deep technical knowledge. In some which way, this shared service and shared repair, right, across the OEMs, across the battery manufacturer, will have to be the way forward, because that's something that, sort of would help. Otherwise, manufacturers are really struggling to set up their own battery repair centers and then to set up this, because it is a very specialized and very advanced one. But the shared one is possible because the kind of equipments which are required for battery service across all the manufacturers is the same, right? So you have an opportunity there. I think we still have some way to go on that, actually.
Thank you, Mr. Rajaram, for that answer. Staying on the same topic, I'd go across to you also, Abhinav, to understand, from your perspective with, the batteries that are running in the fleets on the ground and all. Do you face this challenge as well, and anything that you all have seen come out as a solution for this issue?
Yeah, definitely we have seen the many challenges in the last 4 years till the time of we have incubated ourselves into this industry. As I discussed, I am reiterating my words, the battery life has been increased by many folds since last 4 years because of the improvement in terms of algorithms, introduction of telematics and other kind of technology into that, and the BMS also. Now we are able to understand the temperature, performance, fatigue, and we also use this technology analytics to create a best optimum route optimization, so that we have a good uptime to serve the customers. But from the in terms of standards and in terms of R&D side, in terms of government side, government are putting a lot of push to introduce more manufacturing plants in India, because earlier till last year we've been more depending on the import of the battery. We don't have the manufacturing of battery in India. Till that time we don't have the manufacturing and we don't have the abundant resources by which we can able to utilize and produce the localization of the battery and then reuse it, remanufacture, and then minimize the wastage. We will not able to reach to that level of productivity or kind of standards wherein we can able to reduce the cost of the manufacturing of the vehicles as compared to the IC. So in last discussion which held in the Goa in FAME 3 initiative, we have presented our views to the government to introduce more incentives and PLI kind of schemes in this budget session, which government have already addressed, and we might be able to get some improvement into the subsidy part and the incentivization to put more factories and these recyclable plants, wherein we can eliminate the and reuse the wastage and increase the life cycle of the batteries. And also on the other side, once we localize the things like we did in last from 2010 to 2014, when we have started localization of manufacturing of the parts for the OEMs in India, we have seen that there is a reduction in the cost. The car which supposed to be sold at around 15, 16 lakhs has been reduced to around 10 to 11 lakhs. The same thing will happen in India in next 4 to 5 years once we are seeing the trend will come into the picture, and we are working on that. Thank you.
Yeah, sure, thanks. So I think to my question, I understood that once it starts getting manufacturing here, that's when we can think of repairing it here also. Understood. Coming to you, Amit, again, you selling so many of these vehicles, all different manufacturers, different kinds of chemistries. Do you face this issue a lot as well, that warranties on the batteries coming in big numbers, and then, there's no repairability, and probably the battery is also coming from somewhere outside, so really then you have no choice but to replace them?
Yeah, so there are lots of issues actually. I'm not working with Signy yet, but we love to explore working with you, sir. Um, See, I think there are three components to it. The first component is, the battery chemistry itself and the battery serviceability. Okay, there are many types of cells, and we claim certain kilometers and certain years, and with no real, I'll say, awareness to the consumers. Consumer knows that it's a 3 years warranty, it has to be replaced, but there has to be some education. Example, if I use this mobile phone, my talk time reduces in the 3rd year because the battery degrades. So lithium also degrades over a period of time, and this has to be understood well from the consumer side also. So from the consumer's perspective, there has to be more education on the battery warranty and what applies for. On the battery serviceability, there is no cell balancing tool or machine, or there is no cell diagnostic machine in the service stations across India. So you see the battery and you say it's not working. Okay, that's not about it. We have to have right reports for it. So I think the industry, should come up with more quantified way of diagnosing diagnosing the battery health over a period of time, similar to how we do for ourselves. But if a doctor goes and sees you and say you are okay, then you'll not believe, right? You have to have certain reports for that. So this has to be integrated in the ground level from the service point of view. And the most important point is that everybody is offering 3 years of warranty. Even I've heard somebody offering 8 years of warranty. Okay, for me, it has to be not 3 years or 8 years, it has to be, I think, quantified to kilometers he drives and the driving conditions. Example, if somebody is driving same scooter in Northeast and somebody is driving the same scooter in Rajasthan, somebody is driving the same scooter in Goa, how can the warranties be same? It's a different terrain altogether. The weather is totally different. The driving condition is totally different. Warranty for the last mile is also different. Okay, so I think it needs much more common education, service network, and geographically, acquainted battery warranties for us to give a better, I think, support to consumers.
Thanks, Amit, for those points. And I think you touched upon that important aspect of diagnosis also. And, I would like to bring that point over to you, Anushri. So in, normal recycling of vehicles, we've also seen that there is a model whereby, because that vehicle comes to the recycler, say after 15 years, 20 years, and it would have gone outside the authorized service network of the OEM. So the recycler also is able to provide some inputs to the OEM on, say, the degradation of the different parts in the vehicle, so on and so forth. Similarly, when you are recycling batteries, maybe, they will come to you once the vehicle is outside the warranties and it's outside of, the OEM service network. Have you also explored something of that sort, like, feeding back to the manufacturer, what is the state of that battery when it's come to you? Is it X number of cells that have, become non-functional, or is it something else that has happened in that battery pack, which could probably be also valuable inputs for the manufacturer for future design of batteries?
Right, I think that's a great question again. And so what happens is there's also between the manufacturers, OEM, and the recyclers, there comes a refurbisher. So the refurbisher plays a critical role over here as well. Because if it is still have some lives, it's not an end of life yet, it goes back to the market. But usually what we as recyclers do, we get the end of life batteries. But still, we do have batteries and cells with some part of charge in it. So what we do, first we have to discharge it and then it goes ahead in the processing unit. But if still has some charges which is still to the market is in the same format. But if it is something which is not more of any usage and it has almost reached its end of life, then we discharge the batteries before recycling. And now we also are working on a patented technology where these charges, we can use electricity with that as well and generate electricity. And so in the future plants that we are bringing up, so this is another important component which is a part of it.
All right. Thank you. Thank you, Anshi, for that answer. And still, since we are on the recycling topic, I'll go to you, Rituraj, with a question as well. Now, say you own your own batteries as well and the charging as well, and you have it across the country. What sort of steps are you taking for sort of effective management of these batteries, say for a second life or say even for a recycling perspective? So I would like to understand your experience on that.
Sure. So I think I'll just go back to one of the questions earlier, right? Like the quality of batteries in general in India in last 5 years has gone up massively. I know last year we had AIS 156, right? And that has definitely helped in the positive direction. But in general, the quality of battery packs being produced now versus maybe 5 years back has gone up massively. Be it BMS, be it cell-to-cell joining, be it the kind of quality checks we do at the input of manufacturing a battery. All of this has massively gone up. Right? That's first part. Second is we mentioned about the BMS, right? BMS being the brain of the battery, right? Just breaking down a BMS just does 3 jobs, right? It senses, it uses the data that comes from sensing, which is voltage, current, temperature, to make sense of it using SOX, state of charge, state of health, power, etc. And third thing is, as a selfish component, it protects the battery, right? So, and these BMSs are now becoming, they actually do these things. Also, they have IoT devices on them, right? So how I would put it is, first of all, the quality of battery packs has gone up massively. So the life that a battery gives now, right? And this is not just for Xponent, like around the landscape in India, now people are promising 5 to 8 to 10 years of battery life, right? Which is a reality. So I think the best way to be sustainable is to give a long battery life, which is happening as we speak. Second is predictive maintenance is a lot of focus because you have a smart device on the system, right? With data, you can do a lot of things. So those are aspects that we are also taking care of. We also have to understand in a battery pack, a lot of things can be serviced, a lot of things can't be serviced, right? So these are some of the things that people are doing. And again, summarizing, like the best way to be sustainable is to make sure the battery life is like massive, right? So 5 to 8 to 10 years, that's the best way to be sustainable.
All right, thank you, Rituraj, for that perspective. And just sticking on that perspective, and going across to you, Mr. Rajaram, you also have experience in deploying storage solutions, right? Could you share insights on some of these challenges and opportunities with second life of batteries and also their eventual recycling?
Absolutely, yeah. So I think we were just alluding the previous speakers. I want to just continue from that point. Today, I think the general consensus is you have battery for automotive application, and then there is an end of life goes for recycling. We are seeing this spectrum is getting nuanced out now, right? So one, it is just the definition is just not recycling, but we are seeing multiple steps in between. One, of course, you take this battery, as Rituraj was talking about, can we refurbish and then extend the warranty, right? So that's the first aspect of it, right, for the automotive OEMs. The second one is take that, and then we are seeing that quite a bit of cycle life is left, even at the UOL of automotive battery, which can be used for an ESS application. Then do we sort of take that and use it for a second use application, which can be for ESS, which is not as strict in terms of, the discharge current requirement or a power requirement which can be used. And of course, you talked about, scavenging what is left of that before it goes for recycling. So there is this, these pieces of puzzle which are emerging, much better, and we are seeing that in each one of this stage, there is a clear, value that can be egged out by the, the folks, the stakeholders, right? So today, for extending a warranty, the OEMs obviously, are able to see the value that it's getting created. Similarly, in our experience, when we were using it for an ESS application, we are able to offer this at about 30 to 35% lower cost when compared to an equivalent one. That also is a lot of value rather than directly taking it for a recycling. So we do see a lot of opportunities there. But of course, it does not come with easily, right? Otherwise, it would. So the challenges today is, of course, data, right? So today the data is there, but in order for you to predict, whether it can be refurbished, whether it can be second use case application is possible, we need access to the data. This today is still very proprietary, very OEM specific. If I were to take somebody else's battery pack, becomes difficult for me to get. Number two, the battery packs themselves are not designed for second use application, right? So today, the upfront cost is so dominating that the battery packs are all hard welded, not designed with the second use in mind, right? So clearly that's putting a hardship on that one. Third, for the recyclers especially, with the cost which is coming down, what used to be at about $50-60 for an NMC or an NCA pack is about $20 for an LFP. And with sodium ion coming in, it may be about $5. So the value that can be egged out by the recyclers are going down. So what it means is that the scale and efficiency of operation is going to make a big difference there. But the last but not the least, it is all going to sort of converge where, all of this will have to play, where you have to go through the sequence to echo out a better value is how we are seeing it, Ashik.
Thank you, Mr. Rajaram, for that very, very clear perspective, very lucid answer on that one. Thank you very much. At this moment, we'll take a small pause to also welcome Dr. Yogesh Bhatia, who was stuck somewhere earlier, but now he's been able to make it to the venue, so we'd like to welcome him on stage as well. So while he is coming on, maybe I'll have a question for you as well, Amit. In terms of, a lot of these vehicles come to you, are in their network, are in the fold. So how do we also, look at probably second life of batteries for some of these vehicles, or even promoting recycling, including, doubling up the dealerships as collection centers for end-of-life vehicles to supply to recyclers then?
Yeah, so I think most of the customers don't know what to do with the batteries. I was speaking to her also in the morning that, it's very important for us to understand the implication of battery disposal, one from personal health perspective and second from the environment perspective. But it's also important for us to understand that if somebody comes with a second-hand battery, will it be replaceable? And if it is going to be replaceable, can we assess the cell life? And can we give him some cost for him to upgrade to a new battery? If we are able to do that, it will involve much more involvement from the consumers, so that the life cycle of the battery is well assessed by certain tools. And we say, okay, we'll pay you not scrap value, but let's say XYZ, so that you can replace the batteries, and upgrade yourself to better batteries. So I think from that perspective, it's a movement more than any steps which has to be taken. And the market is ready. I traveled across India, so I'm seeing so many people driving electric scooters nowadays. So it's a movement which is catching up. It's more or less utility for them to save money, their hard-earned money. It's also important for us to understand that, okay, when we say there's no maintenance cost in the electric scooter because there's no engine, but what happens after 3 years? If we can erode that or remove that anxiety that, okay, come up with your battery maybe in the second year itself. Why you want to wait for the third year and cry about your scooter not performing? Let's come in the second year, we'll give you the better price for the batteries. That's when the difference is going to happen.
Thank you, Amit, for that answer. So, you guys, since you've just joined, maybe I'll go across with a question to you. Some of that's been discussed earlier, but maybe your perspective is also important. As we all know, you took over LML and then, launched a T2-wheeler with the name Star, right? From your perspective, a vehicle, an E2-wheeler, of course, it's the body, it's the style, it's the ride handling, it's everything. But a lot depends also on what the battery is bringing to the table in terms of performance, in terms of longevity, etc. So what has been some of your experiences in this field and, any specific steps that you've taken in terms of management of that battery, not from a BMS standpoint, but management in terms of what type of battery, what type of, charging will it support, what would be the battery size, etc., so as to bring in a fine blend of this also at the right price point?
Firstly, I should say thanks for inviting me in TWR session. As in electric vehicle, the battery is a very critical component in the two-wheeler industry for the electric vehicle. because battery cost is around 45% of total product. So जैसा कि legacy brand LML का है, तो हमारी ड्यूटी बैटरी में भी एक अपना डिफरेंट यूनिक इनपुट देने की बनती थी। तो हम लोग एक मोस्ट एडवांस बैटरी पैक क्रिएट किया है, जो कि टू व्हीलर इंडस्ट्री के लिए एक नया आवाम होगा। हमारा बैटरी पैक एक्टिव सेल बैलेंसिंग सिस्टम के साथ होगा, रिमूवेबल डिटैचेबल बैटरी होगी। साथ में हम लोगों ने हाई ग्रेड प्रिज्मेटिक सेल्स यूज़ किए हैं, जो कि मोस्टली 4 व्हील लग्जरी गाड़ियों में यूज़ होते हैं। बिकॉज विद द ब्रांड नेम ऑफ LML वी ऑल्सो वांट टू ट्रांसफॉर्म टू व्हीलर राइडर कम्युनिटी एक्सपीरियंस फ्रॉम आइस टू इलेक्ट्रिक। अभी जो मार्केट में चल रहा है, लेस प्राइस हाई रेंज, electric vehicle is not a less price. It's good for everyone as a environmentally, it's good for everyone as a good feature solutions. ऐसे बहुत से solution tech हैं जो कि सिर्फ इलेक्ट्रिक के साथ ही पॉसिबल थे। तो LML की इंडो इटालियन टीम ने मिलकर उसको एक्सप्लोर किया है। अब दिल्ली दूर नहीं है, बहुत जल्दी हम आपको LML का स्टार स्कूटर एडवांस बैटरी पैक सिस्टम के साथ दिखाएंगे। साथ में आप लोगों का जो सेशन बैटरी और उसके लाइफ साइकिल को लेकर है। बैटरी लाइफ साइकिल एक डिफरेंट डोमेन है। उस डोमेन में हमारे पास 2-3 बड़े बड़े प्रपोजल्स आए हैं, हम लोग इंटरनली इवेल्युएट कर रहे हैं। वंस वी कंक्लूड हम उसका नाम रिवील करेंगे, हम किन के साथ जा रहे हैं, क्योंकि लाइफ साइकिल ऑफ बैटरी उतना ही जरूरी है जितना आपका बैटरी को गाड़ी में डालना है। तो उसके लिए हम लोग हैंड होल्डिंग कर रहे हैं बिग पार्टनर्स के साथ, जो हमें एंड टू एंड कंप्लीट इकोसिस्टम प्रोवाइड करेंगे। थैंक यू।
Thank you. I think you already answered my second question, but just for a clarification, since you're doing all this innovation on the battery pack side, are you also taking some specific steps for the recycling bit of it? So when you talked about the partners, probably you were alluding to the same, or is anything else that has been done specifically there? One, I understand that since you have detachable cells, so of course the life of the battery the pack can be enhanced by just replacing those cells, but anything else apart from that you're doing for promoting recycling, including also ensuring that the battery always comes back to you at the end of life of that vehicle, etc.
Once you're talking about the life cycle of the battery, as a OEM manufacturer, it's our duty, जो भी गाड़ी में हमारी बैटरी जाए उसका एंड डिस्पोज ऑफ राइट वे में होना चाहिए, और हमारे कंज्यूमर को उसका राइट सोल्यूशन मिलना चाहिए। मीन्स हमारे कंज्यूमर ने जो गाड़ी चलाई उसकी पुरानी बैटरी को लेने की एज अ रिस्पॉन्सिबल OEM मैन्युफैक्चरर, इट्स ओवर ड्यूटी हम उस बैटरी को लें, उनको रिप्लेस करके दें, और उस बैटरी का डिस्पोजल एज अ कंप्लायंस इन अ राइट मैनर में हो, जिससे कि हम उसका लाइफ साइकिल एक राइट मैन्युफैक्चरर के साथ टाई अप करके उसको एंड टू एंड कंक्लूड करें।
Right, thank you. Coming across to you, Abhinav, once more, on, what sort of collaborative efforts do you think are required to promote more and more of recyclability in the battery industry? And, I'll have the same question for you also, Anushri, so after he finishes, you can also add on to that, so that recycling can be promoted to a larger extent. We've seen it's had limited success in case of vehicles right now as a whole, so probably some steps that could be taken proactively as we advance more in the electric vehicle era.
So as I said earlier also, that collaboration is very important, whether it's from the academia, whether it's from the manufacturers, whether it's from the government end. Till the time we don't have the R&D setup, we don't have the knowledge fostering between the manufacturer and the academia, and the problem which we are facing currently is the shortage of the manpower in terms of repairing of the vehicles and the battery. So it is very important to set up the R&D setup, innovation center and excellence center across India, so that the new manpower, which is a new generation which is coming from the engineering college, they are capable to understand the new requirement and the new capability to address, which is electric vehicle. For that, I would say that it's important to fill the gap between the academia and the OEMs, so that different kind of setups have been deployed, whether it was center of excellence, whether it's been other kind of activities, certifications. We have deployed a lot of initiative in our own company. We have trained our driver partners with the help of National Skill Development Corporation to understand the basics, to run the electric vehicle and to handle the level 1 kind of support when any problem comes into the picture at the time of running on the ground. So these kind of system and the initiative has to be taken with the help of the government in terms of setting up the institution and the other activities.
Thank you. Thank you. Anushree, your response on this.
Right. Adding to my previous speaker, a few things that we have to keep in mind if we want to really enhance this, and it's an urgent need as well. First would be looking at the logistics of how we are collecting it from the local community or the OEMs. So as he rightly mentioned that there has to be collaboration. Now the biggest challenge is how are we taking it among all the stakeholders, be it the manufacturers, be it the local person, anybody, and recyclers or the waste collectors. The biggest challenge would be how to get it to the recycling facility. First, because it is not a normal waste that we can bring it back from truck or just anywhere. We have to have some certain protocols which are already there, and the CPCB in the October 2023 updated its mandate about how we have to carry the packages, and it's still work. We work closely with the Pollution Control Board and about how to manage the battery waste. So what we did at Atero was we made a robust system of logistics and operative system of collecting from the entire country. So as of now, we collect e-waste and lithium-ion battery waste from everywhere in the country, all the state except Andaman and Nicobar. So just few technical points I just want to mention that when we bring back the batteries, it has to be in a wooden box, for example, because the electrolyte might cause fire and it's hazardous to again health and nature. So these are critical small things that has to be brought in the mandate. The regulations is already working on it, but there has to be stronger enforcement towards it. Second is about the awareness. As we previously spoke about it, we can do a lot of awareness in the school at community levels or through social media or through influencers, which is a big deal nowadays, or maybe through Bollywood celebrities, right now we are already doing a campaign called Clean India Movement, where we go and collect with an awareness campaign from households, societies, universities, institutions. So this has to be enhanced at a bigger platform. And manufacturers and OEMs play a pivotal role in this, because without them, the enhancement cannot take place at a bigger level. And next, I would say that regulatory framework has to be more robust. It is already at a nascent stage, it is building up. But in the coming years, with the advent of more EV batteries and the end-of-life battery vehicles, so we do need a mandate from the OEMs. Now the EPR, the producers have big responsibility, and EPR is a big credential that we are working on. So we also, as a Atero recycler, we also provide EPR certificates, which the refurbisher will not provide to the producers. So that EPR has played an important role about bringing it as a take-back mechanism for the recyclers and the manufacturers, creating a big bridge between that. So these are the points that really needs to be taken care, and we are already working on it, but it has to be a big-time collaboration between all the stakeholders in the society.
Thank you. Thank you, Anushree, for that answer. Final question before we go across to the audience also is to you, Rituraj. Given the rapid urbanization, one that is happening, second, the kind of stress that fast charging puts on the grid, how do you see a big role evolving in terms of battery energy storage systems, smart grids, etc., in order to be able to realize this?
So in general, yes, if we look at down the decade, right, there's definitely need for smart grid systems and maybe decentralized grids, right? Those are things that will definitely come up. As we stand today, EVs account for 1% of the volume of vehicles on road, right? And it's a positive growth that is happening. Second is, if you look back at the trend, right, where charging used to take 4 to 6 to 8 hours of charging time, right? People would have a certain time window where they would charge the batteries, either at night or at daytime, early daytime, right, or during the lunch time. One of the benefits of fast charging is also you can charge when you want. That in general tries to amortize the load over. Yes, there is a spike load on it, but it's amortized because different users actually have the option of charging at any time. They're not constrained ki, oh, my battery is down, I need 6 hours to charge, right? So that is one part of it. But yes, down the decade, we definitely see as the volume grows up to 10, 20, 30%, smart grids coming up, decentralized systems coming up. So those are definitely things that, and I think a lot of good companies have already started working on it to provide solutions.
Sure. Thank you, Rituraj. So, with that, I think I'd like to open it up to the audience. If you could please identify yourself and also state who that question is for. So, we start with you, the gentleman right there. Yes.
Yeah, hi, my name is Raghav. Very quick question, and this is to the entire panel. You have, let's say, fresh cells coming in, for example, for the BESS, right? So fresh imported cells from China, prices are going down, let's say, $100 per kilowatt hour to 90 to 80 and so on, right? And you have this end of life or refurbishment sort of feed coming into the BESS sort of space. So just wanted a comment from anybody on how does this sort of this clash, because you have fresh cells which are coming down in price, and you have this end of life cells or refurbished cells which are sort of coming in, and so the price, so some comment on this economic factor for fresh cells versus refurbished cells.
Yes, Mr. Rajaram.
Yeah, it's a great question. The technology, evolution on lithium-ion battery is going to continue. We know at least for the next 10 years, it's going to be, new forms of, new variants of lithium. There are going to be, more innovations happening on the cathode side. Anodes are getting better with more silicon, lithium metal, and, electrolytes are getting into solid state. You have now sodium-ion battery, all of them. So, to answer your question, I think, and it has been fluctuating. If you were to look at the lithium-ion price, it was the highest to 2022, and then now we are seeing that there has been a significant price drop. We do see that there is an opportunity to eke out in terms of, the value. But I think this window is, small at this point of time as we speak, right? Because there is a global glut, and there has been, sort of a, downward trend both in China as well as in US. But what we believe is, in general, if you were to sort of look at this more holistically, there is a value addition that can be egged out in this process. But at this point of time, I agree with you, the value is, fairly narrow, actually.
Thank you, Mr. Rajaram. I think we have another question here. Yes, please.
Thank you. This is Praveen. I'm interested in understanding the importance of standardization and characterization, right, in terms of specifically on the battery side. So I like maybe Amit, Rituraj, and Venkat. So specifically in terms of characterization, which needs to be kind of emphasized right from the manufacturing stage of a cell till the recycling portion of it. How do you see the cell characterization importance in terms of whether non-destructive or destructive type? Any comments? I just have a follow-up question once I hear of the thoughts. Yeah, Amit, Ritu, and Venkat.
Try to take a crack at it, and then maybe. So, characterization, absolutely no doubt, it's absolutely critical. I know that there are folks in the world looking at characterization vis-a-vis traceability in a holistic aspect. For example, there is what is called as a battery passport, right, which is currently, for those of us who are interested, can go to Batteries Passport, where it talks about the cell, right from where, the minerals were mined, to the place where it is, refined, to the place where it is manufactured, to where it is getting into a battery pack with respect to the, the characterization of the pack, to where the vehicle it goes, all the way till the recycling. I think this is something that got to happen for India as well. I know, I think when Anushri was talking about, the battery waste management rules of August 2023, this was one of the discussions that had happened as well. But not still yet in the, as part of the policy, but I'm pretty sure this is going to happen. And that's going to be very critical, because today, I think we know the issues of, I think we call it as a cobalt red, right? In terms of, cobalt getting mined from, these places which are, which are really, really, bad from, from a child labor and so on. And similarly, nickel pickle, right? What's happening in Indonesia. It's important for us to make sure that when we are talking about sustainability, all of these aspects are taken into account. And, battery passport could be one such example.
Yeah, thanks for putting the battery passport, because again, the question is around that. again, the characterization in terms of batteries is quite kind of underweight. That's where a lot of consortiums are being kind of promoted by both state governments and central government. And of course, I could see Ritu, so their team was also part of it in the last event, which was kind of emphasizing on the battery in terms of characterization, giving importance for non-destructive. And you touched upon the second portion in terms of how this could also be extended towards. Any thoughts on digital twin, starting from mining till recycling, maybe to you as well? So I think you touched upon nicely on the transportation and other areas. Because, I mean, coming from a global e-mobility perspective, I think quite a lot of these things already matured that we are not into it. The passport, for example, battery passport, are the digital twins in terms of mining till recycling. Any thoughts? Because I think Indian market is quite maturing, and we don't need to see that it will take another 3 years, 5 years to really think about it. The think tanks are already started about it. But I think I just want the industry people to resonance, sound about that, and then it's a good time to start. Just want your thoughts.
I think it's a very relevant question again. So let me give you an imaginary circle all of us can imagine. So what happens is we go to mining goes to metal refining, that goes to the next step of cathode active material or anode active material, then we go to the cell manufacturing, battery manufacturing, end of life, then we again go to mining. So what recyclers as we do is we cut the mining part and the metal refining part. We close the circle from lower end of life itself. From end of life, we go to the cathode active material because the materials we get after recycling are the battery grade pure materials. That's why it's also called urban miners. We are an alternative to the normal mining sector as well because we cannot keep mining for ages. Right now, it is a necessity, of course, and everybody was very happy that Kashmir and Rajasthan found out the new lithium surplus in the mining industry. But it's very hazardous again to both environment and health. But we also have to see if it is only concerning to environmental options or also economically viable or not. So at this stage, it will be very not correct to say that recycling is the only option. But in future, we do envision a world where recycling becomes a major section of replacement of mining from natural processes. As Sir rightly mentioned about what happens in Congo for cobalt or in Argentina for lithium. So more and more with UNs and all the COPs coming up and all the compliances for ESG, you have to be more careful about it. So you also have to meet your ESG compliances about moving towards net neutrality. Let me just give you an example of few numbers. Sorry if I'm taking longer time, just a couple of minutes. So what we did a calculation at Atero of how much we are emitting as in terms of GHG emissions, because we do want to be, because we are expanding internationally now. We are opening up in US and Europe and Indonesia recently. So what happens is when we compare to the baseline emission, that is the mining, if we mine, for example, aluminum or lithium carbonate, for example, in the brine or the hard rock, if we mine lithium carbonate, and what if we recycle and bring back lithium carbonate through recycling, we save about 98% of GHG emission. So it's only 2% of emission that we emit as compared to the normal mining. For example, if we take for aluminum, if you mine through the natural processes aluminum and the one we recycle and get back from the recycled end-of-life products, we have about 67% of GHG emissions. So this much we are saving, and this will be very important, if not today, but in the coming years for all of you. As a manufacturer, as a producer, that you have to meet your compliances. As Sir mentioned about the battery pass, it's already in Europe now. You know about the CBAM, this border adjustment mechanism for carbon. So carbon trading and carbon emissions is becoming a very popular terminology. It's not a buzzword anymore. So this is how we are moving towards more about recycling industry as well. Thank you.
Thank you, Anushree. I think we have time for just one last question before we...
So my question is just a one-liner. So, between lithium-ion batteries, we have different categories. We have LFP, we have NMC, we have LT also, right? So which chemistry within lithium-ion is going to win the race in the long run? Within these three chemistries, in terms of safety, in terms of performance, obviously in terms of scalability and price.
Yeah, I don't believe one chemistry, there is no winner-all chemistry here. That's my take on this. Depending on the application, you would have different chemistries. For example, for a telecom tower, for example, right, where safety is predominant, energy density is not a problem. low cost is important and high cycle life is important. You are going to have one type of chemistry. For low commercial vehicle, you would need a little higher density. There is going to be one chemistry, and I definitely do not think that there is going to be one winner take all here. At least so predominantly we are talking about NMCs and LFPs. Another 3-4 years down the line, I'm sure the discussion is going to be talking about lithium sulfur, sodium ion, and going to be about solid state batteries maybe about 7-10 years from now. Given that, so we will have to, I think that's the key thing for India, right? So one, how do we make sure that we are able to play for the future, right? I think one critical one is going to be where, we are not dependent on the critical minerals. We are not dependent on, our big neighbor, for the processing and so on. We will have to pick a technology which is going to be playing to our benefit there. One example could be sodium ion, right? Clearly, this is something, any company which has got, deep technology, one could do that. So that's my short answer because the time is up.
Yeah, I think it's very important to have the recipe maker in-house so that he can tweak the chemistry in the face of even the geopolitical changes that are being talked about. So I think that'll be key. On that note, I think we've had a wonderful set of insights come out here, and therefore this picture of battery management and recycling, I think the pixels that will go into making this a beautiful picture have all been spoken about today. So I thank each one of you for sharing your insights, and also thank you all as an audience for your patient hearing. Thank you very much, everyone.
Thank you all the panelists for the very interesting and yet interactive session we had today. Thank you so much. So everyone, now we move forward for a nice networking lunch break. As you all guys already know, that networking is the key reason to attend the conference, just as you are attending today, the TWF. So enjoy your lunch and enjoy the interaction you're going to have today. And we'll meet back at 2:50 p.m. sharp. I request everyone, please be back here by the 2:50 p.m. today. Thank you.